Dealing with asbestos-containing Orangeburg conduit requires a systematic approach to ensure safety and compliance. Firstly, identify and confirm the asbestos content. Conduct thorough inspections to identify sections of Orangeburg conduit. Obtain samples for laboratory testing to confirm the presence of asbestos. Notify appropriate regulatory authorities, for example, the Occupational Safety and Health Administration and the Environmental Protection Agency. Secondly, develop an asbestos management plan. Establish a detailed plan outlining safety protocols, disposal methods, and potential contingencies. Engage a qualified asbestos abatement contractor to handle the removal and disposal. Thirdly, remove the asbestos-containing conduit. Isolate work areas and establish containment zones. Use appropriate personal protective equipment for personnel involved in removal. Carefully remove asbestos-containing conduit following established abatement techniques. Dispose of the removed material in accordance with regulatory guidelines. Fourthly, clean and decontaminate the work area. Remove all asbestos-containing debris and thoroughly clean work surfaces. Conduct air monitoring to ensure no residual asbestos fibers. Fifthly, ensure proper documentation and record keeping. Maintain detailed records of all asbestos management activities. Obtain clearances from regulatory authorities to verify proper disposal. Cost considerations are significant when dealing with asbestos. Asbestos abatement can be expensive due to the specialized equipment, personal protective equipment, and disposal requirements. Factor in the cost of laboratory testing, management plan development, abatement, cleanup, and regulatory oversight. For additional guidance, contact local waste management authorities for disposal guidelines specific to the area. Consider alternative methods to address the existing conduit, such as relining or encasing it with a non-asbestos material. Seek professional advice from environmental consultants or certified industrial hygienists to ensure compliance and minimize risks. Stay informed about regulatory updates and best practices related to asbestos management. Working with asbestos-containing materials necessitates adherence to stringent safety procedures and regulatory requirements. The first step in dealing with Orangeburg conduit suspected of containing asbestos is a thorough identification and confirmation process. This involves carefully inspecting the existing duct bank system to locate sections of the conduit. Orangeburg conduit, historically used in underground applications, is known to sometimes contain asbestos fibers, which pose a health risk if disturbed. Once identified, representative samples must be collected and sent to a certified laboratory for asbestos testing. This testing will definitively confirm the presence and type of asbestos. It is crucial to use accredited laboratories and follow proper sampling techniques to ensure accurate results. Upon confirmation of asbestos, the next critical step is to notify the relevant regulatory authorities. In the United States, this typically includes the Occupational Safety and Health Administration, which oversees workplace safety, and the Environmental Protection Agency, which regulates environmental protection. These notifications are legally required and ensure that the authorities are aware of the situation and can provide guidance or oversight as needed. Following notification, a comprehensive asbestos management plan must be developed. This plan serves as a roadmap for safely and effectively managing the asbestos-containing material. It should detail the scope of the work, the specific procedures to be followed, the safety protocols to be implemented, and the disposal methods to be used. The plan should also outline potential contingencies and emergency procedures. Given the complexity and risks involved, it is highly recommended to engage a qualified asbestos abatement contractor to handle the removal and disposal process. These contractors have specialized knowledge, training, and equipment to safely manage asbestos-containing materials. Selecting a contractor with a proven track record and proper certifications is essential. The actual removal of asbestos-containing conduit must be performed with meticulous care to prevent the release of asbestos fibers into the environment. The first step is to isolate the work area and establish containment zones. This typically involves erecting physical barriers such as plastic sheeting to prevent the spread of contamination. The work area should also be clearly marked with warning signs to alert personnel of the asbestos hazard. All personnel involved in the removal process must wear appropriate personal protective equipment, including respirators, disposable coveralls, gloves, and eye protection. The specific type of respirator required depends on the level of asbestos exposure anticipated, but a minimum of a half-face respirator with high-efficiency particulate air filters is generally recommended. The removal of the conduit itself should be performed using established abatement techniques. These techniques are designed to minimize the disturbance of asbestos fibers. For example, the conduit may be wetted down with water containing a surfactant to help suppress dust. The conduit should be carefully cut or broken into manageable pieces and immediately placed into sealed, leak-proof containers. Under no circumstances should the conduit be dry cut or handled roughly, as this can generate significant amounts of airborne asbestos fibers. Once the asbestos-containing material has been removed, it must be disposed of in accordance with regulatory guidelines. Asbestos waste is typically classified as hazardous waste and must be transported and disposed of at a permitted landfill that is authorized to accept asbestos-containing materials. The waste must be properly labeled and packaged to prevent accidental exposure during transport and disposal. After the removal and disposal of the asbestos-containing conduit, the work area must be thoroughly cleaned and decontaminated to ensure that no residual asbestos fibers remain. This typically involves using a high-efficiency particulate air vacuum to remove any visible dust and debris. All surfaces should be wet wiped with a detergent solution. Air monitoring should be conducted to verify that the air within the work area is free of asbestos fibers. Air samples are collected and analyzed by a certified laboratory to determine the concentration of asbestos fibers in the air. If the air monitoring results are below the permissible exposure limit, the work area can be released for unrestricted use. Comprehensive documentation and record keeping are essential for demonstrating compliance with regulatory requirements and protecting against potential liability. Detailed records should be maintained of all asbestos management activities, including the initial inspection, asbestos testing results, notification to regulatory authorities, the asbestos management plan, the removal and disposal process, and the air monitoring results. These records should be retained for a specified period of time, as required by law. Obtaining clearances from regulatory authorities is crucial to verify that the asbestos abatement project has been properly completed and that the work area is safe for occupancy. These clearances typically involve submitting documentation to the regulatory authorities and undergoing an inspection of the work area. If the authorities are satisfied that all requirements have been met, they will issue a clearance letter or certificate. Cost considerations are a significant factor in any asbestos abatement project. Asbestos abatement can be an expensive undertaking due to the specialized equipment, personal protective equipment, disposal requirements, and labor costs involved. The cost of laboratory testing, management plan development, abatement, cleanup, and regulatory oversight should all be factored into the overall budget. Obtaining multiple bids from qualified asbestos abatement contractors is recommended to ensure that the project is completed at a fair and reasonable price. In addition to the core steps outlined above, there are several additional considerations to keep in mind when dealing with asbestos-containing Orangeburg Conduit. Contacting local waste management authorities is essential to obtain specific disposal guidelines for the area. Disposal regulations can vary depending on the jurisdiction, so it is important to ensure compliance with local requirements. Considering alternative methods to address existing conduit is also worthwhile. In some cases, it may be possible to rely on or encase the conduit with a non-asbestos material rather than removing it entirely. This approach can be less expensive and less disruptive than removal, but it must be carefully evaluated to ensure that it effectively manages the asbestos hazard. Seeking professional advice from environmental consultants or certified industrial hygienists is always a good idea. These professionals can provide expert guidance on all aspects of asbestos management, from identification and testing to removal and disposal. They can also help to ensure compliance with regulatory requirements and minimize risks. Staying informed about regulatory updates and best practices is crucial for anyone involved in asbestos management. Regulations and best practices are constantly evolving, so it is important to stay up to date on the latest developments. This can be achieved by attending training courses, reading industry publications, and consulting with regulatory authorities. Handling asbestos-containing materials is a complex and challenging task that requires careful planning, execution, and adherence to regulatory requirements. By following the steps outlined above and seeking professional guidance when needed, it is possible to safely and effectively manage asbestos-containing Orangeburg conduit and protect human health and the environment. When planning an underground duct bank system and encountering existing Orangeburg conduit that may contain asbestos, consider the following to ensure a safe and compliant approach. Initially, a preliminary assessment is critical. Before any physical disturbance of the existing duct bank, conduct a thorough site assessment. This assessment should involve reviewing historical records, plans, and any available documentation related to the age and construction of the duct bank. If Orangeburg conduit is suspected, it should be clearly marked on site maps and plans to alert all personnel working in the area. The next step is material sampling and testing. Due to the potential presence of asbestos, assume that any Orangeburg conduit is asbestos-containing until proven otherwise. Engage a qualified environmental consultant to collect samples of the conduit material. These samples should be analyzed by an accredited laboratory using polarized light microscopy or transmission electron microscopy to confirm the presence and type of asbestos fibers. The results of this testing will determine the appropriate course of action. Next is the development of an asbestos management plan. If asbestos is confirmed, a comprehensive asbestos management plan is essential. This plan should detail the procedures for handling, removing, and disposing of the asbestos-containing material. It should also outline the safety measures to protect workers and the environment. The plan should be developed in accordance with federal, state, and local regulations and should be reviewed and approved by a qualified asbestos professional. Worker training and personal protective equipment are key elements of safety. All personnel involved in the project who may come into contact with asbestos-containing materials must receive proper training in asbestos awareness, handling, and safety procedures. This training should cover the health risks associated with asbestos exposure, the proper use of personal protective equipment, and the procedures for containing and disposing of asbestos waste. Workers should be provided with appropriate personal protective equipment, including respirators, disposable coveralls, gloves, and eye protection. The type of respirator required will depend on the level of asbestos exposure, but a minimum of a half-face respirator with high-efficiency particulate air filters is generally recommended. Engineering controls and work practices are crucial to minimizing exposure. Implement engineering controls and work practices to minimize the release of asbestos fibers during the removal process. This may include wetting the conduit with water to suppress dust, using local exhaust ventilation to capture airborne fibers, and enclosing the work area with plastic sheeting to prevent the spread of contamination. Carefully remove the conduit in sections, using hand tools rather than power tools to avoid generating dust. Place the removed conduit in sealed, labeled containers for disposal. Next, waste disposal and documentation must be handled properly. Dispose of asbestos-containing waste in accordance with federal, state, and local regulations. This typically involves transporting the waste to a permitted landfill that is authorized to accept asbestos-containing materials. The waste must be properly labeled and packaged to prevent accidental exposure during transport and disposal. Maintain detailed records of all asbestos-related activities, including the initial assessment, sampling and testing results, the asbestos management plan, worker training records, waste disposal manifests, and air monitoring data. These records should be retained for a specified period of time as required by law. Consider air monitoring to ensure safety. Conduct air monitoring during and after the removal process to ensure that asbestos fiber levels are below the permissible exposure limit. Air samples should be collected and analyzed by a certified laboratory. If air monitoring results exceed the permissible exposure limit, work should be stopped immediately and corrective action should be taken to reduce fiber levels. When dealing with existing underground utilities, there is the potential for encountering other hazards. Therefore, always perform a thorough utility locate before beginning any excavation work. This will help to identify and avoid any buried utilities, such as gas lines, water lines, and electrical cables. Contact the local call center to request a utility locate before digging. When removing portions of the old existing concrete encased duct bank, it's best to use hand tools and avoid heavy machinery that could damage surrounding utilities or structures. Carefully break up the concrete encasement to expose the Orangeburg conduit, taking care not to disturb any asbestos fibers. If the Orangeburg conduit is located near other utilities or structures, take extra precautions to protect them from damage during the removal process. This may involve shoring up the surrounding soil or structures to prevent collapse. During the design phase, consider the routing of the new duct bank to minimize the need to disturb existing utilities or structures. If possible, avoid areas where Orangeburg conduit is known to be present. If it is necessary to cross or parallel existing utilities, provide adequate clearance and support to prevent damage. If the existing Orangeburg conduit cannot be removed without disrupting other utilities or structures, consider alternative methods for addressing the asbestos hazard. This may include encapsulating the conduit with a non-asbestos material or abandoning it in place. Always consult with a qualified asbestos professional to determine the best course of action.